Now that you know a bit about networking and network packets, it's probably a good idea to start thinking about protecting your network. A firewall is one of the key security measures necessary for a secure network. Linux has a number of firewalls available to the InfoSec practitioner that can be crucial to securing their systems without the high cost of commercial systems. It only requires a bit of knowledge and training. A firewall is a subsystem on a computer that blocks certain network traffic from going into or out of a computer. Firewalls can be either software or hardware-based. Hardware-based firewalls generally are used to protect a network and the computers on it, while a software-based firewall protects the system hosting it. Iptables is a flexible firewall utility built for Linux and other *Nix-based operating systems. It uses the command line to set up policy chains to allow or block traffic. When someone tries to connect to your computer, Iptables automatically looks for a rule to match the type of traffic. If it doesn't find a match, it falls back to the default action. The Iptables firewall was developed by the NetFilter project and has been available as part of the Linux kernel since January 2001. As Iptables has matured over the years, it has developed the functionality of many of the proprietary commercial firewalls. Iptables is made up of some basic structures known as tables, chains, and targets. Let's look at each of these. Tables. Tables are an Iptables construct that defines categories of functionality such as packet filtering or NAT. There are 4 tables: filter, NAT, mangle, and raw. Filter is the default table if none other is specified. NAT is used to rewrite the source and/or destination of packets. Mangle is used for packet alteration, such as modifying the TCP header. Raw is used for configuring exemptions from connection tracking chains. Each table has its own built-in chains, and the user can define their own chains. Chains are lists of rules within a table. For our purposes here, the most important chains are input, output, and forward. Input: this chain is for packets destined for the local system. Output: this chain is for packets leaving the local system. Forward: this chain is for packets being routed through the local system. Match: a match is where a packet meets the condition established by the rule. Iptables then processes the packet according to the action in the rule. Targets: Iptables support a set of targets that trigger an action when the packet meets the condition of a rule. The most important of these are accept, allow the packet to pass; drop, drop the packet; log, reject, drop the packet and send back an error; and return. Installing Iptables. Iptables comes installed on nearly every Linux and *Nix system, but if for some reason your system doesn't have Iptables tables installed, you can download it from the repository. Kali sudo apt install Iptables. Configuring the default policy. Before we begin configuring our Iptables, we must first decide what will be our default policy. In other words, what should the firewall do to packets that do not match any rule? To see the default policy on your policy chains, simply enter
Kali sudo iptable.
As you can see in the screenshot above, our chains are all set by default to accept. Most times you will want your system to accept connections by default, but on very secure systems you may want to set the default to block and then write a rule for every type of accepted connection. This is very secure, but very tedious and maintenance intensive. For now, let's leave the default policy to accept. Iptables help. Next, let's look at the help screen for Iptables.
Kali sudo iptables ha.
In the first of these screens, you can see the key options A, D, and L. They are all uppercase and they append A, delete, D, and list, L, the chain, respectively. In the second screen, we can see the options S, D, and J. These are all lowercase and indicate the source address, the destination address, and the target, respectively. Create some rules. Next, let's create some rules. Let's assume that you want to block any packets coming from IP address 192.168.1.102. To create this rule, we simply do the following. A. This appends this rule to the chain. Input looks to match packets coming to the local system. S sets the source address of the packets. J sets the target, in this case, drop. We can do the same for the entire subnetwork by using CIDR notation or 192.168.1.0/24. If we want to drop packets destined for a particular port, We can use the P option followed by the protocol, TCP, and the port, destination port, followed by the port, SSH. If we wanted to accept connections to the website www.amazon.com, we could build a rule that accepts outgoing connection, output, over the TCP protocol, PTCP, to Amazon.com, damazon.com, Kali sudo iptables, A output, PTCP, damazon.com, J accept. It's important to note that iptables will do a DNS lookup only at the time of the creation of the rule. If the IP address changes, the rule will become ineffective. For this reason, it is preferable to use the IP address of the domain. If we wanted to block access to any other websites, we could create the following two rules. Kali sudo iptables, A output PTCP, to port 80, J drop. Kali sudo iptables, A output PTCP, to port 443, J drop. The order of these rules is critical. Iptables will search the rules until it finds a match. This means that if the last two rules, dropping ports 80 and 443, were placed before the domain rule, the user would never be able to reach Amazon.com as the drop rules would match before reaching the domain rule. So when the local system attempts to connect to Amazon.com, they are blocked and the browser times out as seen below. Finally, we can view our table by using the L or list option. To delete a table and start over, we can flush F the table.
Kali sudo iptables F.
Now, when we list the table, we can see that we have a clean slate for creating a new table. Summary: iptables provides the Linux practitioner and cybersecurity professional with a powerful and flexible firewall. With just a bit of knowledge and practice, they can create an effective firewall rivaling the more expensive and complex commercial products costing tens of thousands of dollars.